Hi, today I want to try a little bit of an experiment. Tomorrow I have to give a demo, so I was working on preparing it. I thought I could share it, and it's totally unscripted, so probably things will explode, but that's, I guess, the fun of it, right? So let's see if I can share the screen, because otherwise that's already okay. Good. So today I want to show you a demo about the Starlasu pipeline. The idea is that when we work on a code base, we want to process it in step. And so we we create a pipeline for the specific code that we have. Sometimes we want to analyze a code base, so at the end of the pipeline we should get some files containing statistics, graphs, and stuff like that. Or sometimes we want to migrate a code base. So in this case, the output of the pipeline will be the migrated code. Now, I'm just preparing a simple demo, and here I have a script written in Python that just trigger the various steps of the pipeline. And then, okay, some steps are finishing. Let's see if something explode. But yeah, so far another step is finished. Now, this is a simple code base based on an open source project written in RPG that we are processing just to give you an example. For a real code base, it takes, unfortunately, much longer. But here we have some files that appear. These are the snapshots created at the end of each step. In this case, we have a pipeline where we start initially with an empty code base, and the first step 0 in this case, is the steps in which we load the file. So we look at the existing files on disk, and we create a representation of this file with its name and its content in our code base. The second step, look at all these files, parse them, and attach an AST to them. Then we have semantic enrichment, which calculate types and resolve symbols so that we know if we have, I don't know, a function called foo and we have a function called tofu, we connect that function call to the definition of foo. And finally, in this case, we have a step about adding markers, and we will see what we mean. So these files, this snapshot, we can look at them because basically, well, let's create these. These are basically files containing a series of Lionweb files. So they're zip files containing Lionweb files. So I can load them. And here I can see that I have one node which contains some code, the code of the files that I took a look at, that I parsed, and its name. So from this open source project, I test this name. Not too exciting. Now, if I look at step 1 instead, okay. You see why it's so exciting to have live demos. I don't know what went wrong, but let's try again. Maybe I just managed to mess up my my demo, and I deleted all the files to make it more realistic. So that's not great. Let's see if I have if step 2 works. Otherwise, I'm afraid that I will have just to talk over it and explain. That's very strange. The step 1 is broken while step 2 is loading. So I need to take a look at this. But that's why I like to do lives, unscript, real demos, because it brings back some excitement. Okay, now if I look at certain file here, I should see that I have the AST. So I have a compilation unit, I have various elements representing the content. Now, for example, I don't know, there will be some string literals, for example, here. Okay, there is an entire AST. Now we are not looking at the content of the AST. But before looking at the final state of the code base, I want to show you another aspect of this pipeline. In this pipeline, we process the content that we have and produce the nice snapshots, but we could also generate artifacts. And in this case, one artifact that we generated was we call the migration plan. The migration plan is the optimal order in which we should translate files. And basically, we sort them so that we translate first the files that do not have any dependencies on other files. And this is why we need to resolve symbols before. So that, for example, I can look at an RPG file and see that is referring to some data structures defined in another file. So we'll translate first that file. Right? So we sort the files considering the dependency and their complexity, so that we translate the one that use the minimum amount of constructs first, and then we move to more complex files that may have dependencies on the files we have already translated. So in this case, we generate this migration plan. Okay. But then, as the final step, we load our file. There is more content, so it's taking a little bit more. But good things comes to the people who wait. Okay. Here, I did something different. I wanted to show you this. But let's see if it works. Then I explain it, because if it doesn't work, there is no point explaining it, right? So let's see this. Okay, now I have a monitor statement and I have an annotation over it. Now, what is the idea? We proceed in steps organizing a pipeline because we want to decompose a very difficult problem, that is translating a code base or analyzing it, in a series of steps. One step could be a step where we recognize certain structures and we add markers, so that later on we can use these markers for more complex analysis or to drive the migration. For example, here I wanted to show you this. I define a piece of code that look programmatically for monitor statements which have one error clause, and in that error clause they just call one function that has a name starting with R. It's very difficult to pronounce for me, so maybe I should pick another example. But I want to say that whenever I encounter a monitor statement of these characteristics, I want to add a marker on it. And this is precisely what I do. This marker is called an annotation, and so I can then use this information in the next steps to maybe translate this differently. So I will say, we specify rules that says for monitor statement with this annotation, translate them in this way. while for other monitor statements, you will use the default migration for monitor statements. So this is an example in which we decompose the problem into smaller problems. There are a lot of things that I didn't go into details, but basically Starlasu is now based on LionWeb, a language engineering, let's say, format or language engineering specifications that we co-developed with very smart people. And now we use LionWeb as the format in which we export the states, the snapshots of our pipeline. So we can then process them with all the libraries that are compatible with LionWeb. But we can also visualize them with this simple web application that I developed and that works for all LionWeb compatible files, including ours. But in general, it's a very useful tool to inspect existing LionWeb trees. So we had some excitement in this live, very happy about it. It's nice when something crashes and you have a sudden surge of adrenaline and you have to try something else. We managed, so all is good. So thank you and see you soon. Bye.